All right, let's look at number 45. Dealing with a rational function now, 1 over x squared plus 1, and dealing with a is equal to 0. So let's find our general derivative. F prime of x is the limit as h approaches 0 of, all right, and here we go. F of x plus h, we're going to replace that x with the quantity x plus h. I'm trying to decide if I think we should FOIL that out or not. I'm going to leave it not foiled out for right now. 1 over x plus h quantity squared plus 1. Okay, we can always expand that later if we need to. Minus the original function, 1 over x squared plus 1, and then all over h. So there's our initial setup. Now we've got to try to find a way to combine those two fractions on the top. So we'll do that flying x trick I just talked about in problem 42. The first fraction gets multiplied by the second fraction's denominator, top and bottom. So x squared plus 1 gets multiplied here and here. And then the first fraction's denominator gets multiplied top and bottom over here. So that'll get multiplied by x plus h quantity squared plus 1 over itself. X plus h quantity squared plus 1. So what's that going to do for us? Limit as h approaches 0 of, and here we go. Okay, so the first thing we're going to get in the numerator up here is just an x squared plus 1 minus, and then 1 gets multiplied by all of this. I'm going to go ahead, guys, and distribute that minus in there right now. So it's going to be minus x plus h quantity squared, and then we'll have a minus 1 at the end of all that. Now, in the denominator of the numerator, which now moves into the denominator itself, I'm going to leave that in factored form. I just realized, guys, I forgot to write this on the bottom, which it certainly is there as well. Okay, so our denominator then is going to be the binomial x squared plus 1 multiplied by, ooh, this is going to get a little bit ugly. I'm going to need a bracket right there, x plus h quantity squared plus 1. Okay, that's a little bit weird. All right, and then all of that gets multiplied by this h that was down in the denominator before. Now I see one nice thing that happens in the numerator. That plus 1 and that minus 1 cancel out. But it looks like I'm not going to get to see what I need to see in the numerator until I go ahead and expand everything. So here we go. We start with an x squared. That stays right there. But now, yeah, we do have to do the expansion of x plus h squared, and we have to distribute the negative in there. So the first term would have been x squared. It now becomes a minus x squared. Second term would have been plus 2xh. It's now a minus 2xh. And then there would have been a plus h squared at the end. That's now a minus h squared. And the denominator, I'm going to leave it the way it was, x squared plus 1 times x plus h quantity squared plus 1 times h. Now, what happens in the numerator, guys? This is what we wanted to see. The x squared minus x squared cancel each other out. And then, with the two terms that are left in the numerator, they both contain an h. So I'm going to get a little sloppy here, guys. I'm going to pull that h out right above it, which would leave me with a negative 2x minus h. So that takes care of that. And now, this h in the numerator and this h in the denominator completely cancel each other out, and I think our denominator is going to be okay now to evaluate and actually letting h equal 0. So what's that going to do for us? My numerator then now is going to be a negative 2x, and really that's a minus 0, and there's not much point in writing the minus 0 there, so we'll just leave that as negative 2x. In the denominator, we still have x squared plus 1 out in front. Then in brackets, if we let this h become 0, forget about it, and this is just x squared plus 1 again. So there's x squared plus 1, and the h we had after that was gone. So it looks like we could write this as negative 2x over x squared plus 1 quantity squared. And I don't think that one is going to simplify any further than that. So that, everybody, is our general derivative, f prime of x. They want us to evaluate that derivative. I tell you what, I'm going to switch colors here like I've been doing lately, and we'll go to purple. And I forgot my value here. We need to evaluate all that at a is equal to 0. So here we go. Let me slide that up. We're finding f prime of 0. Got it. Oh, well, that's going to be a 0 up in the numerator. I just need to make sure my denominator isn't 0. 0 plus 1 is 1, squared is 1. So f prime of 0 is 0, and that is the slope of our tangent line. The other thing we need is the actual value of the function f evaluated at the same spot. And let me go back here. The original function was 1 over x squared plus 1. So 1 over 0 squared plus 1 is going to be 1 over 1. That's 1. And so that means that the ordered pair 0, 1 is our point of tangency. Okay, so now we're in pretty good shape here, guys. Actually something interesting here. Point slope form, y minus your y coordinate, 1, equals your slope, which is 0. That tells us, everybody, this is a horizontal tangent line right here because the slope of that tangent is 0. But at any rate, it's x minus your x coordinate, which is 0. Well, 0 times anything is just 0, and bringing the 1 to the other side, we just get the line y equals 1, and that's the equation of our horizontal tangent line here on problem number 45.